Alright, you have two objectives today. Your first objective is the students will learn the definition of the complement, and in this case it's the complement in probability, in order to determine the probability of an event not occurring. Okay? And then your second objective is the students will learn the difference between mutually exclusive events and non-mutually exclusive events in order to give the probability of specific events occurring. So in this case, for today and next class, we're going to be talking about the probability of multiple events occurring. So your first objective is on the complement. So we want to briefly go through some notation. So P of E means the probability that the event occurs. So P of E, the event's occurring. P not E means the event does not occur, obviously. And so you can either occur or not occur, but those probabilities should always add up to 1. Which means the probability of an event not occurring, so that would be the complement, so the probability of an event not occurring might be written like P not E would be 1, so the quantity of 1 minus the probability of the event occurring. Because, again, it can either occur or not occur. So a lot of these examples are going to deal with 52 card decks or 6-sided dice. As always, if you have a question on the number of cards or the number of spots on the dice, please let me know. Alright, so you're dealt 1 card from a standard 52 card deck. Find the probability that you're not dealt a queen. So I might write this as the probability not queen, and that's going to equal 1 minus the probability of getting a queen. Now watch how I'm going to have to write 1. In order to work with our fractions, you need to make sure that you have like denominators. So 52 over 52 represents the 1. So we can easily add our denominators. So again, this 1, because 52 divided by 52 is just 1, minus the probability of the event occurring. So there's 4 queens, so that means you have 4 chances out of 52. And now we can just subtract our denominator. So 4 minus 52, or I'm sorry, 52 minus 4 is 48. So the probability of not getting a queen is 48 over 52, which simplifies to 12 out of 13. Okay? So now the probability of not getting dealt a diamond. So notice the key word here to kind of tell you and point you in the right direction is the word not. Okay, so that's going to, if you see that word, you want to refer to the complement notes. So the probability of not getting a diamond, and I'm just going to abbreviate that. That's going to be 1 minus the probability of getting a diamond, and the 52 out of 52 will change. So if we had 10 outcomes, it would be 10 out of 10. But in this case, we have 52 outcomes, so your 1 is going to be 52 out of 52. Minus the probability of getting a diamond. There's 13 diamonds in the deck, so that means 52 minus 13 are not diamonds, and that gives you your probability, whoa, of not getting a diamond. So 3/4, which makes sense because 3/4 of the deck are not diamonds, because diamonds represent the 4 suits, which is divided into fourths. Okay, so the last one is a little different. We're going to be working in percents. So instead of 1, we're going to be using 100. So we have As I said before, your book has very strange graphs. This graph represents the percentage of fatal accidents, and it's shown through age groups, so you can't see too well on your graph, so hopefully you can kind of transfer the picture through. So you want to know the probability that they are not in the 20 to 24 age group. So if they aren't in that age group, you think with 1 minus the probability that they are. So instead of 1, this time we're going to use 1,000, or not 1,000, 100, because it's going to be 100% minus, take out however many are in the 20 to 24 age group, which 20 to 24, I'm going to point you into this direction. Okay, and it's going to be 19 and 400ths. Okay, so 80 and 9600% of the fatal car accidents were from people not in the 20 to 24 age group. And then now we want to figure out less than 75. So if they're less than 75, they're not greater than 75. So we kind of had to turn that into a different question. So again, we're going to do 100 minus, and now we're going to find where greater than 75 is. Some people think they're not very good drivers. Let's see. Doesn't make up most of it, but it does make up almost 25%, which is going to be 23 and 8/10. So 76 and 2/10% of all traffic accidents are caused by people less than 75, or not greater than 75. You can see here that, the 16 to 19 age group is the largest. So please make sure you're driving safe. Better safe than sorry, as Miss Bailey likes to say. Alright, so that was the complement. Mainly you're going to see questions, if you want to put a star, you're mainly going to see questions like number 1. Just for convenience, the graphs don't copy very well, so you won't see as many graph questions. Alright, moving on to mutually exclusive and not mutually exclusive. So, you are either one or the other. So hopefully you can kind of look at this nice depiction. Mutually exclusive, you have the probability of A and the probability of B. And you can see that there's no overlap, so they don't really affect each other. And then here again, if you have the probability of A and you have the probability of B, you can see that there's some overlap. So I'm going to go through some examples to show what a mutually exclusive event is. A mutually exclusive event are two events that cannot occur at the same time. So I'll give you some time to write that down. So the big key word here is the probability of A or B, and you're going to have to decide if they're mutually exclusive or not. And then you just add the probabilities. So I'm going to go through and see. Here we have the probability of getting an ace, or the probability of getting a king. These are, and I'm going to abbreviate here, mutually exclusive because you can't be an ace and a king at the same time. They don't depend on one another. So if you're an ace, you can't be a king. Rolling a 6 or an odd number. So the probability of rolling a 6 or the probability of an odd number. Again, a 6, you can't be a 6 and an odd number at the same time. So these are mutually exclusive. They cannot occur at the same time. in your world, taking Algebra 2 and geometry are mutually exclusive events because you can't take Algebra 2 and geometry in the same year. Only maybe, I don't know anybody that does, but it might be a rare occasion. But again, you can't do two things at the same time. Okay? So, you want to maybe highlight this formula or make it stand out because you're going to have a couple different formulas depending on what type of events you have. And in this case, again, if they're mutually exclusive events, two events that cannot occur at the same time, then you just add their probabilities. Okay? So, if we look at our first example, one card is randomly selected from a deck of cards. What is the probability of selecting a king or a queen? So you might want to say, why is this mutually exclusive? Well, you can't be a king and a queen at the same time. So here's how it might look like in shorthand. And again, so we're going to add the probability of a king plus the probability of getting a queen. Which means we're going to do, there's 4 kings, so 4 out of 52 plus 4 out of 52 equals 8 out of 52. And you're going to simplify that to 2 over 13. Okay? So our other example is if a 6-sided die, what's the probability of getting a 4 or a 5? So you can't get both at one time because a 4 is not a 5. So you might want to make sure you pay attention that this is the or probability because next class we're going to see and probability. So you might also want to make that note that it's the or. So we're going to add the probability of a 4 plus the probability of a 5. So you only have one chance of getting a 4. You only have one chance of getting a 5. Adding those two together, you get 2 out of 6, which simplifies to 1/3. Okay? So, mutually exclusive events. Two events that cannot occur at the same time. So here's your real life examples. You can't have be an ace or a king at the same time. You can't roll a 6 or an odd number at the same time. You can't take Algebra 2 or geometry at the same time. Okay, so not mutually exclusive events are events that can occur at the same time. And this is going to be a little different. The formula is going to be the probability of A plus the probability of B minus your overlap, which means the probability of A and B. And we'll explain as we go through. So here's some not mutually exclusive events. The probability of getting a heart or the probability of picking a king. So this can happen at the same time because you could be the king of hearts, which means you are a heart or you're also a king. So this could happen at the same time. So I might abbreviate this non-ME. The probability of rolling a 6 or an even number. This could also happen at the same time because a 6 is an even number. And then you could also take Algebra 2 at the same time you're taking consumer math. Normally, you can't take, just kidding, never mind, forget I said that. But I was going to try to say Algebra 1. This is not mutually exclusive because you can take Algebra 2 and consumer math at the same time. Okay? So, looking at our first example, suppose the cards are shuffled and you randomly select one card from the deck. What is the probability of selecting a diamond or a picture card? Okay? So, this is not mutually exclusive because you could be the Jack of Diamonds or the Queen of Diamonds, which means you're a picture card and a diamond card at once. So we're going to have to do the probability of being a diamond plus the probability of being a picture, so I'm just going to abbreviate that, minus the probability of being a diamond and a picture. So that's a D and a P, I see. Okay. So probability of being a diamond, there's 4 diamonds. No, just kidding, there's 13 diamonds in the deck. So 13 out of 52 plus there are 12 picture cards, also known as face cards, in the deck. And then you're going to take out the repeaters. So there are 3 picture cards that could also be diamonds. So what you would just do is 13 plus 12 minus 3, and that gets you to 22 over 52, which simplifies to 11 over 26. So again, we will help you figure out these numbers, but you will have to figure out, what formula to use and when. Okay? So what makes this not mutually exclusive is you have a Jack of Diamonds, which means you also have, a Queen of Diamonds. And you also have the King of Diamonds. So those are your 3 overlaps, because they're a diamond and a king or a picture card. Okay? Alright, and then so a lot of times you'll see the card problems, the dice problems, or the spinner problems. So this is equally probable that the pointer will land on any one of the 8 regions. If the pointer lands on the borderline, you spin again. Find the probability of an even number or a number greater than 5. So again, this is not mutually exclusive because you could be an even number that's also greater than 5. So we're going to do probability of even plus the probability of greater than 5 minus the probability of an even greater than 5. So, probability of an even number. Well, there's 8 total numbers, so half of them are even, plus the probability of a number greater than 5. Can't include 5, so there's 3 of those. So here's the numbers that are greater than 5, and 2 of them are even, so you have to take those out, and we simplify to 5 over 8. So what makes this not mutually exclusive is 6 and 8 are even and greater than 5. So again, if 2 things can happen at one time, they're not mutually exclusive. So here's our examples again. You could be a heart and a king at the same time, the King of Hearts. You can be a 6 and an even number at the same time, so those 2 things could happen. And you could take Algebra 2 or Consumer Math at the same time. Ooh, I forgot about this one. Ooh, well, let's decide. Is this mutually exclusive, which means they cannot happen at the same time, or non-mutually exclusive, which means they can? So, you have pepperoni or mushrooms. The probability of picking a mushroom or a pepperoni? Is this mutually exclusive? Well, hopefully you realize that this is not mutually exclusive because you can pick a piece that has pepperoni and mushroom on it at the same time. So you can have the best of both worlds. So this is not mutually exclusive. Alright, so please make sure that you are doing the correct colored paper. If you are one of those people who are doing the purple, make sure you pick up the purple. If you're in the white category, make sure you pick up the white. I do think it's a good idea for people from the purple group to work with people from the white group, because both papers have something different on them that can help you out. Okay, so hopefully you can see which group you are in.